Okay. Can you hear me clearly now? Okay. Yes, sorry for the technical problems. And hello, everyone. Welcome. I'm very glad to be here. I love physical conferences because I can meet with a lot of people passionate about software development, best practices, DevOps activities, maybe software testing, software quality. And here today, this is what we will do. We will talk about software qualities, quality aspects, and how we can improve the quality in our products and the software that we are developing. We will deep dive into the topic and we will discuss about how we can talk to bugs. I mean, even in the first place, do bugs speak? We will talk about this. They do. I will explain what I mean by talking to bugs. But first of all, let me introduce myself. This is Mesut. I'm from Turkey, but I'm living in Japan for almost 2 years. And I'm a QA engineer for maybe 13 years. I worked for lots of different companies in lots of different domains. And yeah, what I'm doing is trying to improve the quality. It can be in lots of different ways. Like you can define lots of different test cases to cover the specifications or the requirements of the product, or you can run lots of different test scenarios. You can implement test code to develop and automate it to be able to run automatically over the pipelines to integrate to CI runs. You can do lots of things. But of course, there is no certain way to improve the quality. You can do lots of things. You can give feedback in lots of different ways. So in this talk, we will mostly focus on the talking to bugs. And this is what I'm trying to do in my daily activities as well. I'm not only running the test cases or trying to just develop some test code, but in the meantime, I'm trying to look to the product from the customer's perspective. I'm trying to walk in end user's shoes. This is the empathy and trying to look from their eyes. Because, you know, it is always different. We are testers, we are developers, we are already familiar to use the specifications of the product. But it is not same for the customers or the end users. When we deploy our products, it will be the first time for them to use this product. So maybe they will not be that familiar to use it or use these specifications. So we should be aware that they may have some difficulties to use the UIs, APIs. It may not be that much straightforward that we think about it or we expect. So what we have to do is maybe we should think more about the usability of the products. Not only the functionality, but the usability, the performance, so lots of different aspects. So after this long introduction, let's start talking about the issue and the topic itself. But here I put some contact channels for me. Please do not hesitate to reach out. And I would be more glad if it will be more interactive, like if you have any questions, and not necessarily only questions, if you have any opinions, and if you have similar experiences, like you tried to monitor the bugs, and what insights did you collect? If you share at the end of the presentation, that then we can discuss over that. I think you can post your questions or opinions even in Japanese, so it will be translated. Or even in the room, you can ask. I'm sure someone will translate into English. So this is the brief agenda for the talk. We will first introduce what I mean by talking to bugs. How we can talk to bugs, or how they are talking. Bugs are not like us. Normally, they don't speak our language, but they talk somehow. So we will discuss about how it is possible. And then in the second part, okay, then after we start talking to them, what can we talk? What information they can give to us? This we will talk, and we will discuss lots of different insights that we can get from the bugs that we have in our products or the software. And finally, maybe the most important and interesting part is doing this with the help of machine learning. Because when we are dealing with data, large data or any amount of data, we always may use or utilize machine learning in our activities. So I'll share you a case study in which I tried to use machine learning to manage the bugs. And what I did, how I classified them or clustered them. I will show a few examples. So let's start quickly. The first thing, are they talking to us? Yes, they are, because bugs have a lot of information, a lot of valuable information. So it is like simply like we are sitting in a room and there's one guy sitting in front of us. We know that he is super intelligent and informative. But if we are not interested in talking to him or her, then we will not get any information from him. But normally he is super beneficial. If we talk to him, we can learn a lot. He is quite intelligent and of great wisdom. So we can get, there's a huge opportunity there. So we should use. So we should be able to know how we can talk to bugs. So how we should know their language, and their language is asking some questions to them, like, what is the story of you? What is the background of this bug? We should investigate, we should dig, and we should try to get some answers, like when you were born, who created you, and on which component you were found, maybe on which component of the product you were raised, or from which category you were created. Like, are you a functional bug? Are you a performance bug? Who you are? This answer maybe we should follow, and we should track to find some answers. So let me share some stories from my personal experiences that I have. Then maybe I should be more convincing you that you are talking, the bugs are talking. So the first story that I want to share with you is a communication that I have done with one of the bugs who was an old bug, which was an aged bug, which was open for a very long time. So the story is like this. We were working on a problem, on an issue that we have. And after a long root cause analysis, we found out the root cause, why we had this problem. But eventually we figured out that normally there was already an open bug and was open for a very long time. So at the end, we tried to understand why this bug was open, was reported, but not resolved. And no one was taking some or paying some attention to this bug. It was open and just forgotten somewhere. So we did not have any checklist. We did not have any follow-up tasks for this bug. Just someone someone created this bug, and we just did the triage, and we ended up that this bug was not a major bug, but it was a minor one. Okay, everything sounds good. Every bug may not be a major issue or a critical issue. So it's okay to evaluate this as a minor issue. And it is okay not to solve it immediately because we have some maybe more important things to do. So it's okay to postpone to next sprints. So we can just put it in the backlog. But what we missed in this case is we forgot to track this bug. We just labeled as a minor issue and then did not care at all. We just forgot about this bug. So what happened is, even if not directly from this bug, because itself is not a major issue, it is a minor issue, but some side effects happened. And eventually we get this problem. So the lessons I learned from this bug after I talked to him or her from different aspects, like talking what was the problem, talking about what the problem was. We figured out that no one was interested in talking to him or her. So this was the biggest lesson learned. Even if we do not or we won't solve it immediately right away, it is still okay to keep it in the backlog, but at least we may have some checklists or we may have some dashboards on which we can understand that we have a bug over there. It's open for a very long time. And it may have some potential risks. This was the biggest lesson learned that I had. And then after this experience, I started to create some dashboards to see if there were some bugs open for a very long time. Because it is very likely if we have a huge backlog, then some of the bugs are recently created, but some of them were maybe created very long time ago. So the second story that I want to share is the best friends band that I call them, because they are merging together or disappearing together. I mean, for example, some performance issues are merging together with some gateway related functionalities. For example, if our gateways are not functioning properly, then in the meantime, we are having some performance issues or security issues as well. What I mean in short is it may depend on the project or the product itself. But what I mean and what I'm trying to say is some issues may be related to each other. If we have some gateway issues, then we have some security issues as well. They are connected to each other. So if we figure out these kind of relationships, if we are able to do this analysis, then we can avoid having some security issues, right? Because we know that they are somehow related to the gateway issues. If we avoid having some gateway issues in the first place, then we won't have security issues either. So figuring out these kind of relationships are very important. We can get some these kind of insights that we can guess if I do not deploy the gateway properly, then most probably I will have some authentication or authorization problems as well, which will result in some security issues. So these kind of guesses I can have if I do this analysis. And finally, I will share a story related to a sweet escape, which is an escaped bug. And what does escaped bug means, or escape of a bug? What does it mean? Normally, we try to keep the bugs in our environments. We love bugs, but we don't want to let them go in production environment. We don't want them to be faced by the customers. So what we do is try to find them in the early stages, like in-house activities. And then if we find them and reveal them, we can fix them before deploying to the customers. So in this case, they will be avoided in the first place before releasing or deploying to the production environments. So why don't we want bugs to go to production environments? Because, you know, if it is found in the later stages, it will be much more costly. It will be extra cost. And it will be more difficult to fix. The running code is already in the production environment and we have an issue there. So maybe we should revert some code. We should do an extra deployment, a lot of things. But if we found it first in our testing activities, then it would be much more easier. Like just fix the code and commit again. If the test pass, then release. It would be much more easier. So in this story, I asked how it was successful to go to the production environment, because normally I thought I covered the specification and I designed lots of test cases to avoid having any bugs, but somehow one of the bugs raised in production environment. When I talked to him, he gave me lots of information like, your test cases are not enough. Maybe you can add these kind of corner cases as well. Or you designed very well, still okay, but you tested this scenario with only a specific range of data. So maybe customers are using some different data, like going over a very simple functionality. If we are testing a multiplication function, then maybe I'm testing this functionality with integers, but what about double values? Maybe we will have with some other type of data. So after trying to understand some insights about the bugs, we can get lots of different aspects that we did not imagine in the first place. So we can have lots of extra information and valuable data from the bugs. So reporting the bugs is very important. This is okay, because we are revealing the weaknesses or the vulnerabilities in the product. So we can fix them and improve them. This is very important. And fixing the bugs is, of course, very important because we are getting rid of the problems or the weaknesses. But how about after all this, after we report and fix, how about going one more time to talk to bugs? What was the problem? What happened over there? Why we had this bug? And for the future activities, what can be the possible activities that we can avoid in the first place before having them in the production environment? So monitoring bugs can help us from the two different perspectives. The first one is we can improve the quality. And in the meantime, on the other hand, maybe we can get some insights from them. Lots of different aspects they can share to us. But to be able to do a good or successful bug monitoring, first of all, we need a transparency. What does this mean is we have to be able to see what is happening very clearly. Everything should be visible. Like if I'm interested on the durations on each stage that I'm spending, like for designing a test case, how much time do I need? In average, like I'm designing my test cases in 2 days in average. This is one statistics that I have. And for implementing the test code, in average, I need 3 days. And to do a code review on this implemented code, maybe I need 3 hours, let's say. So this kind of information that I can get from my processes, from my workflows. But to be able to know this information, I need this data in my tracking systems. Like even if you are using Jira or any other issue tracking system, if I'm updating the status properly and accurately, then I can get this information. But if I'm setting the status in new or in progress, then immediately if I'm closing it without setting to the next stages, then I will not be able to understand how much time I spent after it was in progress until the closure. So we have to keep it very up to date, all the issues, and the system itself should be supporting this transparency. Because, you know, if you use the default status, maybe it is like a very draft workflow is like new, in progress, done, verified, like this. If it is only this, maybe we will be missing something, but we can customize our environments and our systems. If we need another status, like these are okay, but I need more, like sometimes it is duplicated. It is marked as duplicated, or sometimes it is rejected in the first place. Like I'm creating a bug, I'm raising an issue, and it is rejected by the developers. They say that, or the product managers, they say that it is not a bug. It is a normal functionality. So they just reject. And if we agree, then we close it by marking as rejected. So there may be lots of different status. If I need, I should be able to customize my systems and keeping my status up to date. And how we can do monitoring in the best way is doing this manually all the time is not easy. So if we somehow succeed to do it in an automated way, it would be much more easier. We can generate lots of code. For example, in this sample code, I'm doing a query on the API of Jira. So I'm querying for the issues, all open issues or all issues whose status are in progress. I can do any query by generating the data or a body of my query, of my request. And after getting the response, I can parse the response to reach to the information that I'm chasing. Like after I get the response, I can have all the issues with their creation date and the resolution date as well. So if I'm interested in the duration that I need to resolve an issue in average, then what I can do is just subtract the creation date from the resolution date. So I can reach out to the duration in between. And if I divide by the total number of issues, then I can find the average number that I'm interested in. So this kind of queries I can do automatically by the help of coding or generating some code. And after I develop this code, I can put it in a job. Like I can run a nightly job in my pipelines, even if you are using Jenkins or AWS runners, GitHub runner, whatever you are using, you can run this automatically. You can trigger after some actions, or you can schedule, like run this every night. And in the morning, when I go to the office or when I start my PC from home, then this will be the first thing that I will check. If the durations increased or decreased, what happened, I can understand. And this is a sample. Eventually, we will come to this point. After we set up our environment, after we develop our code, eventually we will have this kind of valuable information. Because normally, okay, we get the response and all the data is there, all the numbers are there, they are great. It is very cool to have this information. But if we translate this into some visual graphs or dashboards, it would be much more easier to understand what's happening. Like we can right away see the distribution. Like most of the bugs are still in open status, I can understand, looking at the graph. Because dealing with numbers is sometimes difficult, tricky. But if we have some visual graphs or dashboards, it would be very straightforward to see what's happening in our environments. So in the second part, let's talk about what kind of information we can get. Firstly, we discussed if it is possible to talk to bugs, and I hope you are convinced that it is possible. It is possible to talk to them. It is possible to get some information from them. And in the second part, let's discuss what kind of information they can share to us. So as an approach, what we can follow is we can maybe generate some graphs or collect some data sprint-wise, like this sprint, what data do we have? This maybe we can collect, or we can collect the cumulative data, like from the starting of the project until this moment. So far, how many bugs do we have? This is one thing, this is the cumulative data. Or this sprint, how many bugs did we find? Or last sprint, what was the number? So if we generate some sprint-wise data, then we will have a chance to compare this kind of data or these numbers. Like last sprint, I was maybe more working more efficiently. So this sprint, somehow I found only one bug, or I didn't find any bug. So if I found out these kind of observations, then I can investigate what is the reason. So I'll show you a lot of graphs and different alternatives that we can follow. The first sample that I want to show you is the distribution of bugs across their status or severity levels. All the bugs may have different severity levels, like some of them will be critical, which should be fixed right away, or some of them may be major, minor, or maybe trivial. So these kind of different severity levels we can have, or of course, they all have some different status, like some of them are still open, some of them are under fix, some of them are done, which means the developers fixed already, but done, but not verified. So they are still pending for verification. This status is also important. It means that if it is still in progress or if it is still open, we can push the developers, why it is still open? Please take care of this. Please start working on this. But if it is done, but not verified, then we can push the testers. It is done. It is already fixed by the developers, but you didn't verify this. Please do it immediately or as soon as possible. Because if not verified, they claim that they are done. They fixed the issue, but we are not sure. We didn't verify it yet. Because when we try to verify, we can find out that it is not fully fixed. We have still some issues, or it is fixed, but we may have some other issues, some other side effects. I'm sure you may have some similar cases, like they fix the problems, they fix the issues, but then we have some other issues. It's a side effect of the bug. So when they commit, when they try to change something, okay, this bug itself is fixed, but we have another bug. So it is a side effect. So having this kind of distribution, then we can understand where we have to go, who we have to push, or what we have to ask. Like if we have still a lot of open bugs, the number of open bugs are not decreasing, but increasing in time, then we can investigate what's happening. Guys, why are not we fixing the bugs? Why we are still having a lot of bugs? So maybe we are blocked with some other tasks, but maybe if the trend is always increasing, maybe it is time to stop the development activities. First of all, get rid of these problems. So we can have these kind of results and conclusions. This kind of graphs will help a lot to understand what's going on in our workflows. So it is not only improving the product itself, but it is improving the processes as well. How we are doing our processes, how we are performing our processes or activities. One other distribution we may have is the component of the product on which the bug is found. Like my product here, the system under test, was a microservices product. So we had lots of different services like the asset management, the IoT services, the developer services, the core services, connectivity services, lots of different microservices it had. And what I did is I tried to figure out on which microservice we were mostly finding the bugs. For example, here we can see that 32 or 37, I guess, percentage of the bugs are coming from connectivity services. So if there's a bias on connectivity services, mostly we are finding the bugs over that service, specific service, then we can talk to the relevant team. Guys, most of the bugs are coming from your service. Is there something else that we can do to improve the quality of your service? Or maybe are we missing something? Your commits are merged without running the test. Well, what is the problem? We can try to understand. But first of all, we have to find the root cause. First of all, we have to figure out what is the biggest improvement room in our product or lifecycle. And similarly, we can show the distribution of them among or across their types. Like mostly we are having functionality bugs or security bugs, performance bugs. What type of bugs we are having mostly? This we may analyze. And we may analyze the detection progress in time. Like last month, we found 10 bugs. This month, we found 50 bugs. And next month, it will be maybe 20 bugs. So if there is any unexpected data, then we can focus on this and try to understand what happened, why we had lots of bugs or why we had very few number of bugs. And the resolution duration, it may differ in time because sometimes maybe recently we are resolving the bugs maybe in average in 1 week. But last month it was maybe 2 days. So last month it was 2 days, but this month we are fixing in 1 week. So it means we are fixing in a slower pace. What happened? We can try to investigate. Maybe we reduce the resources what we resort to fix the bugs. Or maybe, I don't know, the bugs are more complicated now. So we can somehow try to understand what's happening. And one more comparison that we can do is created versus result. So in this time, we have 2 different lines, 2 different trends. And what we can figure out is the gap between these 2. If the gap is widening in time, which means we are more having created, but less having result. If the gap is increasing in time, then we may have some action items like stop the developing new features. First of all, let's get rid of the problems because it is increasing in time. So this will help a lot to understand if the gap is increasing or decreasing. And in addition to the dashboards or trend lines, we can have some tables as well. Like from the graphs or line trends, we can understand the number of bugs. But if we do it on a table, then we can categorize them. For example, we can check the number of each bug, but each bug which were created in the last 30 days. And for the ones which were created in last 60 days. So in this way, we can more focus on the bugs which are open for a very long time. For example, on this table, I can mostly concentrate on the rightmost column, like open for more than 60 days. It is open for more than 60 days and still open. I have one issue over there. I can immediately see with the help of this table, but otherwise I will have a huge list in my backlog. It is not possible to see. I have one issue still open, although it is open for a very long time. But if I utilize these kind of tables, it would be very straightforward to see. Yeah, I have one issue. It is open. It is status is open, and it is critical, by the way. Normally, I should fix it right away, but it is still open. And a similar thing I can do similar to the status distribution. This time resolved but not validated. So again, we have one issue which is a critical one. It should be fixed and then verified, and it is fixed but not verified yet. So then I can ask to the possible assignees or the testing teams, why you don't verify still yet? Is there any blocker? Is there any impediment to verify this? If so, maybe we should update the status, because maybe it should be opened again, reopened, right? So if that is the case, then we should let the developer team know. Otherwise, they will not know that it should be reopened. And in the beginning, we quickly talked about this, the importance of escape bugs. We can have more focus. We can more concentrate on the number of escape bugs or the root cause of escape bugs, because in the later stages, if we find them, it will be extra cost, it will be extra difficulty to fix them, and it is a prestige issue. It will be found by the customers. They will report to them. Maybe they will lose their trust to our products. Okay, these guys' products is not that much reliable. I cannot trust their product anymore. They will lose their confidence on our product. So it's very important. It's a prestige issue to have some escape bugs or not. So what we have to do is maybe think from their perspective. I told in the beginning, sometimes for us, we are very familiar and we are experts to use these kind of features, but for the customers, they will be using this for the first time. So maybe they will fall. They will not be able to use this specification, this product, this requirement. So we should think about their perspective. We should guess they may have some difficulty, and maybe we should improve the usability. Otherwise, maybe they will fail and they will complain about our product. They will not be satisfied. And finally, the last section, let's think or discuss about, can we somehow bring the machine learning on the table? Because machine learning is a hot topic, you know. Most of the researchers are working on this. They are trying to adapt machine learning into their development activities or testing activities. So let's see what we can do with machine learning. You know, we can use machine learning for clustering data or classification of the data. So here, in terms of classification, we are talking about try each of the bugs, like they should go into a critical category or minor categories. This is classification already. Or we are trying to find if there is any specific component on which the bugs are mostly found, like is there a weakest point of the product? Is there a specific service on which the bugs are heaped together? If so, I can try to improve that specific service if there's a bias. So this kind of classification and clustering we can do. And what I will share is, in my project, I tried to classify the data. They classify the bugs according to their severity levels. So in my project, we had 6 different severity levels from severity 1 to severity 6, but 5 and 6 were not real bugs, but feature change requests. So the first 4 level is the bug severity levels, 1, 2, 3, 4. And severity 1 is the highest criticality, which is mostly like related to life issues, human life. Like if you have a hardware in your product and if you have a current leakage, then it may harm human life, right? So it is that kind of criticality level. But the other, starting from 2, 3, 4, are the normal critical major and normal criticality levels. So in our project, we didn't have any severity 1 issue. So actually we have 3 different levels, severity 2, 3, and 4. So I'll try to classify the bugs into one of these 3 categories. This will be my classification. And how many samples did I have? In my real project, I have around 900 samples exported from Jira. Those are the real data. So it is a little bit a small data set. Normally for machine learning, we should have a huge data set to be able to generate a model properly. But somehow I wanted to do it with the real data. So I had only 900 samples generated by the users of the project. And of course, you know, for the machine learning, first, you have to generate a model to make your feature estimations or predictions. And to generate a model, first of all, you have to extract the features, which is the first cycle of the workflow, feature extraction. Of course, you can have some extra studies like cleaning the data, simplifying the data, these kind of things, pre-processing you may have. But the first essential cycle is the feature extraction. So in this case, what I did is the data is text or string data. Like someone raised a bug, like on the service, I did my query, but I get a 400 response code. This is a bug. Normally, I expect 200 response code. Normally, I was expecting to get a successful response with the proper response body or response data. But the service or the server responded with 400 response code or 500, whatever. So this is a string, right? This is a text. Someone raised his or her concern. He put a text value into the issue and posted as a bug, as an issue. So normal machine learning, the machine doesn't understand anything from this text, from this string value. So what we have to do is convert this into numeric arrays, numeric vectors. So this is called the feature extraction. So in this case, since we are dealing with text files, I approached a few certain algorithms like bag of words. In this approach, you count the number of the frequency of words. Like you are mostly having like response code. If this is the most frequently faced word in the box, then you can generate your model upon this word, specific word. So you just check the frequency of the words in the text files or the issues in the reported issues, and then to somehow try to convert to numeric arrays or vectors. Of course, you can apply some different methods, specific methods, like there is TF-ID to get rid of the bias. For example, on a specific sentence, you may have 4 or 5 samples of the same word. To get rid of these kind of biases, you can apply some different approaches. But I'll come to the conclusion. So this was the distribution of data. If I want to classify this, you know, to do the machine learning, to perform or to evaluate the performance, first of all, we have to reserve some certain range of data for the test purposes. So first, I reserved the data for classification and then the remaining part for the testing, which means normally one issue was raised by someone and normally he put a label, like he think that this bug is severity 2. But I hide this label because I will use for testing my algorithm. So by hiding this label, I asked machine learning to predict for me. So machine learning thinks that from the past samples, I think this should be maybe severity 2, or maybe the conclusion, the prediction can be, this should be severity 3. The machine learning can say to me. So if it gives the same result that I expect, like normally the label put by a human being was 2, and the machine also says 2, then it means it's a match. It is accurate. So it will contribute to the accuracy in the positive way. Or if the results said by the machine learning and said by the human being are different, then it will contribute to the accuracy of the performance of the machine learning algorithm in the negative way, because it couldn't make the correct prediction, correct estimation. So the result was like this, which means this is a confusion matrix. So which means I can see a bias on the upper left corner. Like normally the actual severity level was 2, and it was predicted as 2. This is the most common. This was the most common result. So the accuracy rate here was 73% accurate. We can think that it is acceptable, but I still think that it was possible to a little bit more increase the accuracy. So what I did is, going on this bias, maybe we can somehow get rid of the bias. So what I did is, normally class 2 samples were the highest number of samples. So I combined 3 and 4 together. Why? Why am I doing this? Does it make sense? Yes, because in my case, if a bug is severity 2 or not, which means severity 2 or 3, 4, whatever, is important. Because if it is a severity 2, then it was a release blocker for us. If we have a severity 2 bug, then we were blocking the release. Guys, we have a severity 2 bug. Stop the release, first fix this, and then release. So deciding on severity 2 or not is important. So now I will classify into 2 groups, severity 2 or 3 and 4, not severity 2. So in this way, the accuracy rate was better, which was around 82%. It is still not very, very high, like over 90%, 95%, because sometimes some machine learning algorithms work very well, like vocal commanding. If you are interacting to your smartphones, or even if you are doing a search on Google, you can do your vocal commanding, right? It is working very well. But in this case, it is a little bit difficult, because even with putting the labels by humans, it may be subjective. Like for me, it is severity 2, but for you, it is severity 3. It is not a minor bug for you, but for me, it is important. We have to fix this. So it was a little bit difficult, but at least we could still use it. 82% is not low. So even though we will not be used as the last decision, at least we can use this to assist our processes. Somehow, first of all, let machine learning do the prediction, and then I can do the last check as a human being. This is why we still have human effort, manual effort. Even if we automate everything, eventually we will have some people in our projects. Replacing people by the machines is not possible. I mean, we can replace some extent of our efforts. We can mitigate some of the efforts to the machines, but eventually we will have some human. Because we will be the ones who will use this product. We will have, or we should have, the last judgment done by the humans. So I'm wrapping up the talk. So what we have discussed throughout this talk is, first of all, we discussed, is it possible to talk to bugs? What do I mean by talking to bugs? How can we communicate to them? What kind of information can we collect from them? And then we discussed what kind of information, what kind of insights can I get from them by analyzing them, and what kind of improvement action items I can have for the future activities. And in the last part, of course, machine learning may help a lot if we properly utilize it in our activities. So thanks for listening. I hope it was beneficial and useful. And if you have any questions, and if we have time, please do not hesitate. Or otherwise, you can reach out to me after the talk as well. Just feel free, and appreciate if you have any opinions. Thanks a lot for listening. Any questions? Sure.
You mentioned that you experienced many places in many domains. So have you ever experienced that kind of situation that it's tough to fix the bug, because you mentioned even a minor bug, once you find maybe it's better to fix immediately. I mean, that's dependable. But sometimes the company, sometimes the business unit is stronger than the development unit, and then like the culture is totally different. Fixing the bug faster, maybe a business requirement faster. In that case, it's quite tough to proceed fixing the bug. So if you experience that kind of things, and how do you, what would the countermeasure?
Yeah, it is very likely. They may say that, okay, I agree, this is a bug, but it is too complicated. Maybe we will not be able to fix this. It is too complicated. Or it's okay, we can go with this bug. I accept this is a bug, but it's okay, we can have it. They may respond like this. Or even they can reject like, this is not a bug. This is normal functionality. So it is very likely to have it. Of course, I'm having these kind of issues. So what I'm doing is, of course, if I believe this is a bug, and if I believe that it should be fixed because it will have an effect on the customers or the end users, then of course, I'm trying to convince them. How can we convince them? Of course, it is very important to have the right way of communication, because if you harsh too hard on them, maybe it will not have any good effect on them. But you have to convince them by attaching some proofs, like what will happen if we have still this bug? Maybe we can get some feedback from the end users. What about their opinions? So we can talk to product teams as well. So it will not be one person's conclusion, right? Because it would be too much subjective. It can be wrong. For example, for me, we have to fix this bug, but maybe I'm wrong. Maybe the end users are not that much interested in using these specifications. So I believe what we can do is collect lots of different ideas, because it should be a teamwork. It's not an individual effort. So get some ideas from the product team, get ideas directly from the end users if we have any contact, or get feedback from the developer team. What do they think? Maybe they can provide some feedback about the complexity or the implementation difficulty. And maybe from the product quality teams as well. So putting all the ideas on the table, then we can judge as a common roadmap. That's what I would suggest.
Okay. Yeah.
Because if it is only one person's opinion, then yeah, you may have some arguments and you may have some conflicts. So we were doing in our projects was we had a board, like change board. One person from product team, one person from development team, one person from quality team. They were having a weekly meeting every week, going over the bugs and deciding if we should fix this or maybe labeling as minor. Okay. So having such a board may help.
Okay, thank you.
Sure. Okay, thanks a lot. I think we are running out of time, but please, if you have any further questions, just let me know. Thank you.